Imagine you want to send a letter to a friend who lives in the same town as you. So you put that letter in your mailbox, and the post office comes and picks up that letter and takes it to the nearest post office, which is 3 hours away. And then they put it back on another mail truck and send it all the way back to your town to have it delivered to your friend. When it was really, they just lived across town or maybe even down the street. Well, in this nugget, we're going to cover Anycast Gateways. And the same concept applies. We want to make sure that our gateways are as close to the source traffic as possible so we don't have to send our traffic way out somewhere across the network in order to get back to our neighbor that's on the same VLAN. In traditional networking, when we have a network segment, call it a VLAN, and we have some hosts, let's say we have a host here, a server, PC, phone, whatever we want, and it wants to talk to another VLAN, so we'll draw this other VLAN separately. So this is VLAN 2, or VLAN blue, whatever we want to call it, and there's a host over here. Now these two hosts cannot talk to each other without a gateway. So what we do is we deploy a layer 3 switch, or it could be a router, and we configure it for what we call switched virtual interfaces, or SVIs. And these SVIs are routing points that I'm designating here with these dots, and the switch itself is capable of routing between those two interfaces. So when the host on VLAN purple wants to send traffic to the host on VLAN blue, it sends the traffic to its default gateway, which then routes it to the SVI on the blue VLAN and sends it down to its destination. So as we can imagine, we would want those gateways to be as close to the traffic sources as possible. In other words, if we have our switch up here with the two SVIs, and we connect off of that a switch, and connect off of that another switch, and connect off of that another switch, and then maybe go across some kind of WAN link, we're making something up here, but we've got the two hosts down here that are on two separate VLANs. So in this case, we'll call it VLANs 10 and 20, since we're using the same color. So in order to communicate between these two hosts, who are connected to the same switch, by the way, this host would have to go all the way up to its SVI, and then get routed over to the SVI for VLAN 20, and then that would get sent all the way back down to the host. Now where this can really come back to bite us is if we have two data centers. We'll call them data center 1 and data center 2. And we have something called a data center interconnect, or DCI, that links the two. So we have a switch here and a switch here, and maybe it's a pair of switches, and this DCI is extending layer 2 connectivity. So now the question is, where do the SVIs live? Because we have hosts here on VLAN 10, we'll call it, and we have hosts here on VLAN 10. Because if the SVI lives here, then the host on the right has to go all the way across the data center interconnect, which, by the way, might not be a whole lot of bandwidth, just to come back to get routed down to a host that maybe is over here living on VLAN 20. And of course, if the SVI lived on the right, we'd have the same problem in reverse. So what are we going to do? Well, even before we had ACI, we had a concept called Anycast Gateways, which allowed us to build a gateway SVI on both sides of the link, and we would block some level of communications between the two. So for example, we might run HSRP, and we block the HSRP control plane from seeing each other. So the host on VLAN 10 can hit the SVI locally and go right back down, and meanwhile the host on VLAN 10 on the left can do the same thing to get to traffic that maybe is on VLAN 20 over on the left. Now, in order for those to function, those SVIs have to have the same IP address and the same MAC address. And at first glance, we might say, whoa, wait, we can't have the same duplicated IP and MAC addresses in the same environment. But that's exactly the concept of what we call Anycast traffic. Anycast traffic finds the nearest valid destination. And we use this concept in multicast and a bunch of other applications, so this actually works just fine. So how does ACI leverage Anycast gateways? Well, in an ACI environment, we have spine switches, and in our case, we'll draw 2 here. And then let's just draw 4 leaf switches. We could have a whole lot more, we could have less, we could have just 2 leaf switches. So this is our environment, and every leaf is connected to every spine. And in a traditional network where we'd have a core or distribution switch, we'd probably put the SVIs up here, so then the host downstream can come up 2 hops and get to its gateway address, and then of course get down to the rest of the traffic. However, we're not going to do that in ACI, because in ACI, all of the intelligence lives at the leaf layer. So that's even better because it's closer to the traffic source. And so what we can do with ACI is deploy Anycast gateways on every single leaf switch in our environment where it makes sense to do so. In other words, if we have an SVI for VLAN 10, and we have hosts on VLAN 10 on this switch, and hosts on this switch, and hosts on this switch, and all of these are on VLAN 10, we would want SVIs on all 3 of those leaf switches. In this scenario, do we need a gateway on the 4th leaf switch? And the answer is no, and so ACI will not push an SVI out to that leaf switch until there's a host that connects at VLAN 10, at which point it will deploy an Anycast gateway there as well. As a result, it doesn't matter which switch we connect to. If we've got a local host connected to the same switch on a different VLAN, then that traffic flow can stay within the same leaf switch. Even better, there's a concept of an ACI stretched fabric, where we might have additional ACI switches at our second data center that connect into a leaf switch over here. Well, this is exactly what we just drew out in the previous slide with 2 data centers. What are we going to do? Well, ACI is going to deploy those Anycast gateways onto the leaf switches at the remote data center as well. So coming back to our post office analogy, we don't want to have to send our traffic really far away just to come back, especially if we're on the same switch as our destination. ACI uses Anycast gateways to keep as much traffic on a local switch as possible. It does that by deploying an Anycast gateway to every single leaf switch in the environment to which there are hosts belonging to that VLAN. It also deploys Anycast gateways to leaf switches at remote data centers in the cases of stretched fabrics. I hope this has been informative for you, and I'd like to thank you for viewing.